Mic check. Anybody hear me? Okay, I think that's me there. All right. All right. So I'm going to admit up front, I am nervous because this is something I've been working very hard on for 3 months, and I was misinformed / probably misread the time that I have to present this, so I'm going to be going quick. That being said, I'm going to try and do my best. Thank you. First and foremost, does this work? No. Okay, cool. So I'm presenting Arcane, which is AI for makers and person scale problems. That's going to make more sense as I talk about the inspiration behind this. But in order to do a good presentation, the 3 things you have to hit on immediately is you have to tell the audience who you are so that they know that, why they should even be listening to you. You have to tell them what you're going to be telling them, which is going to be self-explanatory in a sec. And you have to tell them why they have to care. So let's cover that basis before I dive into the more particular bits. So who am I? I'm Keith. I'm also half shell. You'll see me on Discord a lot. I'm in the DevX Discord all the time. My expertise is AI and robotics. That tends to be what I care most about. You can message me anytime to talk about maker projects, AI, robotics, but I also do free resume review, free practice interviews for software engineers, so you can reach out to me about that. And I also do free-ish startup consulting. My rates start at a beer, goes up to a bottle of bourbon, depending on how much I'm doing for you. Some of you also already know me from SDX, which is another group where I run the paper club, where I cover in-depth AI topics. The next club is February 18th. I'll be covering the DeepSeek R1 paper, hopefully not talking as quickly as this. And we're actually, I just got text that we're doing a hackathon on Saturday sponsored by OpenAI. We're gonna play with the O3 model, so do check out SDX if you're interested in working on AI stuff. Great group. Now, before I talk about what Arcane is, I need to answer the question of what is an agent. This is all the hype cycle right now. It's in all the news. The problem is that there's a lot of different terms that are shooting around there. And the reason is because some people that are talking are researchers, and some of the people that are talking are charlatans trying to raise money. So it's difficult to see what the actual term is going to be. I am not going to do a debate on what the definition is. I'm just going to say that for now, the definition of an agent is a simple AI capable of completing a singular task that is really good at, right? That's the only definition that I'm going to be using today. But why are agents getting popular? Well, it turns out that those models that we are saying are going to lead us to AGI aren't really good at complex tasks past a certain level of complexity. Similarly, if you give a model too many tools, most models right now is about 4 to 5 tools, then if you go above that number, they get confused, forget how to use the old tools, and they just can't complete simple tasks. So the approach that we're doing right now, that you're seeing across the startup world, are small individual AIs that can do one thing simply well, and then getting them to either collaborate or work together in some possible way. So what's Arcane? It's yet another Pythonic agentic framework. But why is this one different? Why is this one something that I care about? Well, it's designed not for giant corporations to run their latest startup or their web scale thing. It's designed for people to make quick prototypes or people to make task-solving AIs. I'm specifically targeting the maker market with this. It's built to be used by non-professional coders. I want people who aren't good at coding to be able to pick up some simple Python and make a Python project or make an AI project by the end of the weekend. The design philosophy is to make it easy to share and build upon, and I'm going to expand upon that in a second. And it's not beholden to any single platform. It works with all of these models, and I'm going to be adding more. DeepSeek is the exception. I was going to add it last night. Their API has been down for 3 days due to DDoS attacks, and everything's fully open source. So what am I building with this? Well, I'm going to be hunting for a job soon, so I'm going to have an AI that scans job postings for me and let me know which ones are actually worth looking at, research the company, that kind of thing. I dream of having a personal research AI that I can email and it's going to reply back with a nice written article about the topic that I'm interested in. I love to learn about things. I'm building a business leads generator for my friend who runs a small business who wants to basically use human evaluators to find potential leads to sell their journals. And well, that's something that he has down to a process, and we're going to be trying to use AI to do that at scale. And of course, my wife loves this one, private conversational AI that can answer my questions, but also make fun of me. I don't want my chatbot to sound like it works in HR. I want them to have some personality. But that's what I'm building with it. That's not necessarily why you should care about it. So why should you care about it? Well, I want to actually take a look at the Arduino and the Raspberry Pi. Who here has used these things before? Yeah, great. So you guys know about this, but what you might not know, and this is dating myself a little bit, before the Arduino came out, getting into embedded hardware was freaking hard. You had to drop hundreds of dollars on the programmer, hundreds of dollars on the program board, and then you had to pay for the IDE and the right to use the language to program some of them. Arduino completely changed that. It made it so that even grade school children could start to make their own electronics. The Raspberry Pi took that a step further. And from this, we got the 3D printing revolution. A ton of new hardware companies popped up because embedded hardware could suddenly be something you do on the weekend. People were making technology their own. Arduino had this great concept as well, where you could basically produce shields, plug it into the Arduino, and people that knew what they were doing were building components that you could just plug in and use really easily without having to be an expert in embedded electronics. And that was a great idea. So open hardware ignited a new wave of electronics that inspired millions to make personal scale tech. We need the same for AI. We need frameworks not designed for companies, but designed for people to do their weekend project. So basically, that's my mission statement. AI should be for you and by you, and it should not be built to extract your money. So that's a lot of talking. Let's actually dive into the code. This is Arcane in action. I create a Wikipedia search object, which is just a module. I pass it an LLM, which will handle all the stuff for you. I ask it the question, where was Einstein born, as a function, and it returns the result. That's it. That's the whole thing, and it's designed to be that easy. Now, you might be saying, well, okay, it's just asking an LM and you're printing out the answer. It's not. It's actually specifically trained or prompted to know how to search Wikipedia, read the article, and pull the answer from that. But you don't have to know all of that in order to use it. Another example on this one, research the applications of LLMs to robotics, one of my personal favorites. This web searcher agent here, what it will do is, given the topic query, generate n amount of possible queries that it could find the information from, go to DuckDuckGo or Bing or Google, search it, look at the results for all the web pages, from that decide which web pages are worth reading, go to each web page, summarize their contents, then combine all those summaries to create an ultimate summary that you can read. It takes about a minute. But that's a lot of stuff happening at once that you might not necessarily need to know the down and gritty to, but you can start to build stuff with this really quickly. And the primary goal of Arcane is that if you can call a function, you can use this library. And if you really know what you're doing, which some of you, since you're here at a DevX group, I'm guessing you can do way more complex stuff, sure. So the idea that I'm building on is I want basically AI coding to be like Legos. People can play it together, and the real experts will create great cathedrals while everyone else is making fun little car toys they can play with. So terms I'm going to be using throughout is a tool. A tool is a function that does something with some extra niceties. We'll see what those niceties are later, but just think a tool is a function. Keep that in your mind. We have an agent. An agent is a tool that has an LLM. That's it. That's the main definition there. Always remember, all agents are tools, and that's important to remember for a little bit because we'll see why. There are different types of agents. Iterative agents can call itself repeatedly to try and refine something. And then finally we get backend agents, which are agents that can call tools. We'll dive into that later. But you start to see where you can build up on this. And a backend is the term I use for just a framework for handling the tool calls. This is taking care of all the parsing, the prompting, and telling the LLM how to actually handle the tools, what they are, how to call it, and then basically once it outputs something, it'll parse the output to separate the tool calls, call them, feed it back into the LLM. All that's being handled for you. And then there's a word you'll see thrown around a lot called context. That's state that's tracked across executions. So everything I'm trying to make as simple to use and compatibility over everything else. That's the philosophy of everything I'm trying to aim for here. So again, tools are functions with extra capabilities. They have a name, a description, arguments, and a result, and possibly examples. They do something. So let's take a look at one. So this is the tool that we used earlier, or one of them, Wikipedia search. If I print the name of it, it's Wikipedia search. If I print the description of it there, if I print all the arguments, it's going to print that there. The reason this is important is because the way that you tell LLMs how to utilize things is through text. So by programmatically formatting the tool with all of this information, I'm able to format it exactly the way that the LLM wants when I go to do it. That's what the back end is doing. So again, here's an actual tool that we're going to make from scratch. Is that I basically just import tool, I set a name, a description, a set of arguments, and I say that this is the function you're going to call when the tool is called. And then once you have that information, you can go ahead and pass that to an LLM or utilize it with anything else. Here's the tool that I called earlier. You don't have to worry about reading it because it's mostly filler text. 90% of this is just a description of how it works to the LLM. And then the actual function call to the Wikipedia API is that line right there. That's it. And then that's going to find what pages are related to your query for the Wikipedia agent so that I can go and query that page later. Most of this is just describing what is working. And the reason for that is because you want to describe to the LLM how your stuff is working so it can utilize it in the actual stuff. Maybe you already have a function, you don't want to use my tool, that's cool. There's a decorator that will automatically do that. It will actually, if you utilize standard Python comment patterns, the top most popular ones, it will actually parse your, in code, it'll parse your function and your type hints to pull out the description, the type explanations for the different variables that are for parameters, your return type and everything. So it'll take care of all the writing for you at that point. All right, but you're mostly here for the agentic AI stuff. So what about agents? Well, agents, there are two rules. You gotta basically tell the agent what your prompt is, telling it what it has to do, and how to extract the output from the LLM's response into the form that you want for your function. So here's an example. We just have a simple agent. Again, you'd have the description, just like a tool would be. The only two things you need to do on top of a tool is you have to prep a function called prepare prompt, which just returns a giant string prompt of what you're trying to tell the model to do, and extract result, which is you're just trying to take from the string response of the LLM and try and output with whatever it is you're trying to return there. Another way you could do it if you don't want to do the object-oriented approach is I just have this thing here. You can pass them in as functions as well. And it's just really simple to set up and use. I know I'm going quick. Sorry. Iterative agents we talked about. So, but we want to use tools as agents. So we got to talk about backends. So we talked about, okay, who here has used React before? And I'm not talking about the JavaScript framework. I'm talking about the LM approach of prompting models. One or two? So this is basically an approach where you tell models that given a task, it's going to complete a thought. That thought is going to then be analyzed by the LM to determine whether or not it's going to create an action that calls a tool. That tool call gets returned, and then the LM says, based off the task or question presented to me, can I utilize the information from the tool call to say that I'm done for an output, or do I still have more work to do? And then it calls back the thought. And this process continues until you have an output. So this is a backend within Arcane. Similarly, a lot of the open model, or a lot of the model services have built-in tool calling, so we can just plug right into that. We don't have to worry about the parsing and all of that. This one I like a lot. I built this for the hell of it. This is the Python environment backend. You give it a task and it generates a set of code for you. That code is executed inside a Docker container with a socket connection to a special server that is controlling all of your tools, so it can call out, call the tool, return the result, and continue executing just like a function call as if it was local. The resulting code output/exceptions get thrown into a separate agent that reviews and refines it based off a judge and determines whether the task is done and can return a result, or if it has to generate more code based off of the refinement suggestions. And this cycle kind of continues forever until your stuff is done. And then I'm also working, there's also a chatbot backend as well, so you can have a chatbot and several lines of code and then just suddenly have tools. This is a good example of how it works currently. You ask a question, it determines if it needs to call a tool. If it does, it calls it. Then based on the conversation and the personality that you prescribe to it, it's going to go ahead and generate the response for you. And then I have several other backends that are in the work that I won't talk about right now. But the point is that backends do a lot of the work for you. As long as you have a backend prepared, it will automatically know how to handle all the tool calling, tool parsing for you, and be able to handle that. So basically, you just have to experiment with which backend. But once you find the one that works for your task, you can start building like Legos, everything else. So making a backend agent is super easy. All you have to do is create an agent, just like you normally would. And then you have this one function, prepare for backend, which takes your input and then outputs a set of commands or a set of arguments that the backend would expect. That's it. Once you do that, you have all the parsing capability of all the backends and all the tool calling capability there. So this is just another example. This is the Wikipedia search agent that I was talking about earlier, where all it does is take the argument of question and map it to task, and you're done. And the backend will handle everything else, and it will call all the tools for Wikipedia for you, and it will know how to do that. All right, but why am I excited about this? I keep talking about Legos. The original name of this project was Composable Agents. This is where this idea kind of expands out. So I have a Wikipedia agent that does one simple thing. It scans Wikipedia, summarizes the article. I have a web search agent, well, why can't I have a research agent that knows how to call these? Because this is a tool. So if you follow that pattern, you can go from a very simple tool and build up to more and more complex behavior to the point that, yes, this research agent has a simple job. It knows how to call 1 to 4 tools, but those tools inside have tools within them, and those are doing complex tasks, and you get increasingly better behavior as you do this. So how do you do that? Well, that's where we have flow. Flow is basically a set of tools designed to chain together agents and tools in ways that make it useful for you. For instance, the linear tool just allows you to chain responses of agents into each other, or you can throw some functions in there too. So if you need to do some formatting. So you just say, okay, linear, name, description, just because it's a new tool, and you pass in a list of what tools you want to execute in order, and you're done. Conditional, self-explanatory, if, then, or else, same idea. And we have retry, self-explanatory, it'll retry based on certain parameters. Branching is that you have one input, but you want it to fire off to different agents. We have a parallel list, so you have a list of inputs, and you want multiple agents to fire off at once for that web searcher. That's what we had, so you had the list of websites that you want to scrape. You pass that into a parallel list of summarizers, which then on the fly will summarize all of them in at the same time. On air, obvious, fire and forget, also there. And there's several more, but I'm not going to go through all of them. All right, now I talked about state. The one thing that if you worked with a lot of these branching agents, you're really curious about state, because that is something that is kind of maddening to do. This is the live demo portion, so this is where everything will crash and burn. I have a simple thing. This is readable, right, guys? Yes. Okay, so literally I just import my Arcane stuff. I have a little quick start function where I'm telling it boot up the spellbook socket. Spellbook is the cool name for the very simple thing. We have a web searcher that I created. I'm telling it it's OpenAI. I'm asking it that same question we saw earlier, and I'm going to print it. And I'm just going to keep alive until I send it the kill signal. All this is built into that. One thing I am going to warn all of you, I am not good with CSS, so I apologize. All right, so I'm going to just execute that. And, yeah, it's over here. Connect to it. And this is the context that's being passed around. This is all being done for you in the background. That tool, that web searcher agent called 9 separate tools in order to complete its task. I can dial down into exactly what it was doing, what it returned, and what it was thinking at the time throughout that entire process. So for instance, this is the final output. The latest trend in robotics involves those, so on and so forth. If I come to the parallel list, I'll see that, okay, I did this argument here. Here's all the different summaries it was fed out. And then it simultaneously starts summarizing those summaries, which in turn was summaries from different websites and so on. And all this can be debugged here. You can also execute them from here so that if I wanted to, I could say, fire off another search. And that's all handled right here in Spellbook. So this is basically the debugging tool to make it simple for you to utilize these agent stuff. So that's how you handle the context and the state. So what tools are available right now? These are the integrations I've already programmed, and you can utilize to start building up your stuff. You want to send an email, a text message, we got you covered. Web searching, local map search, so this is like, I want a coffee shop near me, we got that covered. Wikipedia, as you saw, we can check the weather. We can read and convert PDFs to Markdown. Websites we can convert to Markdown and read for you for scraping. We do get stuck by CAPTCHAs. Summarization, labeling, we have chat available, some vector and RAG stuff. I want to Arduino integration, home assistant, so we can get to controlling people's smart homes. Playwright integration for better website control, database querying, so that we can get to the point where you can talk to a database and build out that stuff. So these are all tools that are already done or in the works that you can utilize, and I really want other people to start building out other tools for stuff they want. Now, connectors are basically ways to run your agent. Now, one of the things I kind of realized thinking about it is like, wait a minute, the integrating of the agent to services that you actually want to trigger off of is going to be really difficult. So we have to handle that for junior developers or for hobbyists as well. So we have stuff like the schedule, which is you can just set it up to fire off on repeat at a set interval that's kind of human language. It's easy to set up. We have an inbox feature. which is you can have it respond to, connected to your Gmail, have it respond to all your emails or ones that are just from yourself, and then you tell it what agents are going to get past the email. So you can just go ahead and build out things that respond to email. We have stuff that responds to RSS feeds, really easy. This is all you need to do to set it up and pass it to the different tools and agents, and it'll just go ahead and trigger. If you want an API server, you just pass it the tools and agents you have, whether or not you want authentication for it, and boom, you have a fast API server ready to go to treat your stuff. We have a CLI tool, so if you have a bunch of agents that are useful that you want to activate in the CLI, go ahead, pass it. This is all the code you need, and you'll be able to call it just like you call Git in the command line, and it'll take care of all the parsing for you and all that stuff. But what's next? Well, more of everything. I want more tools. I have a lot of bug fixing to do. This is an early stage. A lot of capability and features that I want to add, such as a tool registry, some automatic tool generation for to make it easier on young devs to go ahead and build out the stuff. And mostly I'm looking for a community. So if this is something that you're interested in, or you managed to grasp anything I said at rapid pace today, I would very much appreciate if you joined us at the Arcane Discord. You can find it through the GitHub there. Or if you're interested in building AI stuff, let me know. And utilize this framework. Let me know how it works for you. That's it. What can I answer? Yeah. Question.
Hi. Thanks for the presentation. So from what I'm getting at is, in some ways, agents are just like pre-generated AI prompt engineering.
To a point. So these agents are, so the prompting is pre-generated for the backend to do like, this is how you think, but it's up to you to explain to the AI what you want it to do and some examples of what you want it to do. So it's up to you to handle the last mile prompting. The reason for this is that I want it to be so that if you are a complete newbie at programming and you understand some Python, you can explain in human English what you want the agent to do, and you're still able to get out a pretty good result. But if you are an expert developer, you can still go in and control the exact parsing, how it's utilizing, what kind of pattern is it doing in the background to get the LM to maximize its performance. So all that is still stuff you can still control, but it's also with a simple interface so anyone can use it. Does that make sense? Yeah. Anything else, or?
Any more hands?
Sure.
Thank you for the talk. Great conversation and presentation. So before I ask a question, do you familiar with the N8N.io?
What's that?
With the N8N.io.
I don't know that one.
So technically is after workflow automation, but based with the AI. So my question was like, what's the difference? Because they use AI agents for that workflow. So, but if you're not familiar, then the question will be different. Like, so do you try to solve, eventually your motivation is to create AI native workflow for people?
The hope is to make it so that maybe one day Spellbook you'll be able to compose agents, sure. But my goal is not to make it so that it's a no-code tool. My goal is to make it so that hobbyists and DIYers can say, I want to make an agent for a weekend project to automate responding to this kind of email, and do it. I'm not looking for the ability to make the next, Google. I'm looking for the ability to make the next little hackaday.com project.
Thank you, Keith.
Right, thank you.
Oh, keep clapping. Yeah, go ahead.